Hotel room rates. A travel agent claims that the standard deviation of the room rates of 3-star hotels in Chicago is at least $35. A random sample of 21 3-star hotels has a standard deviation of 22. At alpha equal 0.01, is there enough evidence to reject the agent's claim? Okay, so let's identify the parameter. Okay, the claim is that the standard deviation is at least 35. So my parameter is going to be sigma, not sigma squared. Okay, because this is a test about standard deviation. Okay, so let me write that claim as a mathematical statement. Okay, so it's going to be sigma, okay, is at least, so that's going to be greater than or equal to 35, right? At least 35 is 35 or more. Okay, so this is the claim. And because it contains the case of equality, this is going to be the null. Okay, so this makes the alternative sigma less than 35. Okay? So let's go ahead and find the test statistic. Okay, it's n minus 1 times s squared over sigma squared. Okay, so in the problem, we're given that n is 21. We're given that the sample standard deviation is 22. Okay, and the claim is in terms of the standard deviation. So looking at the test statistic formula, what am I going to have to do for S? I'm going to have to square it, right? Okay, so watch out for that. Okay, so my test statistic will be 21 minus 1 times 22 squared. Now look, the claimed parameter is in terms of standard deviation also, so I need to also square that 35. It would be really mean if they gave one as variance and the other as standard deviation. Wouldn't put it past them, right, because they're evil. Okay, so putting that into the calculator real quick. The lighting is terrible on this in this room. Okay, 20 times 22 squared. Okay, and divide by 35 squared. Do you get 7.902? Okay. All right, so let's find the critical value. This is a lower tail test. Okay, so I'm going to draw a skewed right distribution and shade a lower tail here. My level of significance given in the problem was 0.01. So I want 0.01 in this lower tail. But the table reads from the critical value to positive infinity. Okay, so how much area is to the right of that? 0.99. Right? So I want to read first to the degrees of freedom, which is 20, and then over to 0.99 to the right. Okay, so 20 and 0.99. Do you get 8.260?
21.
Did I make a mistake here? What's the sample size?
22.
No, it's 21.
Oh, is it? Okay.
Yeah, the standard deviation is 22. Okay. All right, well, I just lost my train of thought. Okay, so this is the critical value, 8.897? Oh, sorry, you confused me. 8.260. Okay, now we need chocolate. Okay, so where does our test statistic lie? In the rejection region. I didn't make this quite big enough, but we are in the rejection region. Okay, so we're down here. Okay, so we are going to reject the null in this case. So going back to the null and the alternative, if we're rejecting the null, are we supporting the claim? No. Okay, so the decision is to reject the null. Okay, and the question is there enough evidence to reject the agent's claim? Yes, there is. Okay, so there is enough evidence to reject the agent's claim. Okay? Are we good? All right, let's go.